Alright, so today in Math 3, we're taking our unit circle that we have put together and we're unraveling it. So we're taking that unit circle and stretching it out across the x-axis. And we're going to do that today and tomorrow to graph two different kinds of functions. We're going to graph all of our y-coordinates today from our unit circle. If you remember from the unit circle, your x-coordinate stood for the cosine of whatever angle, and your y-coordinate stood for the sine of whatever angle that you were at. When we graph our sine and cosine functions, we will only be graphing in terms of radians. So if you see our example graph here, as they're going along the x-axis and they're labeling important degree measurements, they're labeling those degrees only in terms, important angle measurements, they're labeling them only in terms of radians, not in degrees. So we'll do the same thing. So let's look at and talk about some characteristics of a sine graph in general. First of all, we've got period. Period is the length of one cycle of our graph. Both sine and cosine graphs are what's called periodic functions. So what we've graphed so far, mainly polynomials, and even with exponentials, the middle of the graph does something, and then the ends does something completely different, and then the ends go on forever in one direction, and they don't change after that. It just headed on forever in that same direction. What periodic functions do, they have a little section like you see from here from 0 to 2 pi, and then that section repeats over and over again. So if I were to graph this in my calculator and look at it, I would see that it goes back up and comes back down, and then goes back up and comes back down, and it will do the same thing on this side. So whenever we graph sine and cosine, we will always graph one of these cycles, one period, but to show that it goes on forever, we have to draw in these arrows that lets us know that the graph continues in both directions, repeating this cycle over and over again. So we can have horizontal stretching and shrinking that changes the length of the period. Typically, the length of the period is 2 pi units long. So from the beginning of our graph to the end of our graph should take us 2 pi units, unless there's been stretching and shrinking. In regular Math 3, we do not do any horizontal stretching or shrinking. So our length of our period, the length of the cycle, will always be 2 pi units. So if you're ever asked that on a test or a quiz, what's the length of this graph's period, the answer will be 2 pi. All right, we've been talking a lot about domain and range. Remember, domain is the set of all x's. Well, if our graph's repeating over and over and over again all the way to the left, and over and over and over again all the way to the right, our domain is going to be all real numbers. Remember, you can write that in both interval and inequality notation. I'm using x's because domain describes x's. Well, the range on my graph, bottom to top, each period is going to hit the same bottom and top. So typically, unless there has been some vertical stretching or shrinking, which in Math 3 regular we do not do vertical stretching or shrinking, but we do deal with the second thing that could affect the range, movement up and down. The range is typically in between -1 and +1, and it does actually hit at -1 and +1. So to describe our range, we will always use two brackets because it actually hits both of the upper and the lower values there. So with our inequality notation, we use the letter y because range is y's, and it's in between -1 and +1, and we do put lower number first and bigger number. All right, the next thing is amplitude. This is where we can, I said we're not applying vertical stretches and shrinks. We actually are. That's what amplitude does. Vertical stretches and shrinks, that affects the distance from the center of your graph, and we call this center our midline, all the way to the top or to our maximum point or to our lowest point. So the bigger this amplitude is occurring, we have a vertical stretch. So we'll see this distance increase. If the amplitude is smaller, we'll see it decrease. So the amplitude is the distance from your midline the center of your graph to either your maximum or your minimum. And then I did mention vertical shift. That's taking our midline and moving it up or down. So take the middle part of your graph and shift it up or down. All right, so here's some important things about graphing the sine function. You don't need to write all this down. Let's just read through it together. This is our typical sine equation. You do need to write that down. We need to know what A stands for and what B stands for. Now, when you get into AFM, when you get into pre-calculus, you'll see it written more like this. These two things we don't discuss in Math 3. So no, this isn't everything that could happen with a sine function. We're just going to talk about two things. We're going to talk about amplitude, and we're going to talk about vertical shift. We're not going to talk about horizontally shifting, otherwise known as phase shifting. We're not going to talk about changing the period of the graph. All right, if the phase shifting is moving left or right, and then we've got the changing the period. In Math 3, we will only be studying amplitude and vertical shifts. We said this earlier, all graphs will have the same period. We don't graph tangent, but sine and cosine have the period of 2 pi. And there will be no phase shifting, no movement left or right. So we can move up or down, we can stretch it vertically up and down, that's what the amplitude does, but nothing else. So your first step, identify what is your amplitude and period. And amplitude isn't just A, amplitude is absolute value of A. Amplitude is never, ever, ever negative. So if I have a graph and it starts with a negative number, we'll see in a second how that affects it, but that doesn't change the amplitude because amplitude is measuring distance, and distance is not negative. The negative tells us about the direction that we're going to start with, and we'll see that in a couple examples. We need to come up with 5 critical points. So our 5 x values, since our graph is never going to be horizontally stretched or shrunk, since we're never moving left and right, the x values for us will always be the same, and they're the same ones we saw on our graph up here. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if you know those 5 x values, you're already part of the way to getting the question correct, because those will always be the ones we use. And like I said, we call these 5 points our critical points. Then we need to find the y values that go along with those x values. So the start, middle, and end. So when we're writing out our points, we're going to have 5 things. We're going to have our start, our middle, and our end. The start, middle, and end y value. So the starting y value we said was 0. The middle one was pi. Starting x value is 0. The middle one is pi. And the ending y value is 2 pi. The y values here for start, middle, and end will always be the same. And they'll always be the same as our vertical shift. So if our graph has shifted up 1, these will all be positive 1. If our graph has shifted down 3, these will all be negative 3. If our graph has not moved, if the midline is still at the x-axis, then these y values will be 0. The remaining 2 points are our maximum and minimum. And typically, just like you see in this graph here, we hit maximum first. That would change, and this is where the negative comes in. If my graph's negative, that means instead of heading up first to my maximum, I'm going to head down first to my minimum. And so our graph would do that instead, go down and then come up. So if that's the case, these 2 points would change. So we find, and we know those x values. I said if you just memorize these, this one's at pi over 2, your minimum is at 3 pi over 2. So we find these corresponding y values by taking whatever midline we're at and adding and subtracting our amplitude. So for the maximum, wherever your midline is, go your amplitude units above. For your minimum, from your midline, go your amplitude units below. And we're going to plot these points, connect them with a smooth curve, and then show the graph is continuing forever to the left and to the right using arrows. So this will make more sense as we get into some examples. Let's look at our first example. All right, so this first one, the graph that we want to see is the graph of 2 sine of x, and we want to graph one period here. So amplitude is the absolute value of your leading coefficient. Well, absolute value of positive 2 is still positive 2. So all this means is whenever I draw my midline, wherever it's at, my graph's going to go as high as 2 points above it and 2 points below it. We said period will always be the same thing, and it is always 2 pi. We do not have phase shifts on any of our graphs. And then vertical shift, whatever's added on the outside. Just like when we see transformations with other kinds of graphs, whatever's added on the outside moves our graph up or down. Same thing applies for sine graphs. So we have a vertical shift of none because there's nothing added. No movement up or down. So when I'm graphing it, the very first thing I want to do is graph my midline. The center of my graph is here on the x-axis. I did not shift up or down at all. Let's fill in our critical points. All the x values I said we need to memorize. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then the corresponding y values. I said a second ago, start, middle, and end will all have the same y value, and they're the same as your vertical shift. If there is no vertical shift, they're all 0. So I should see these points being on my dotted line. When I go to plot them, 0, 0, pi 0, and 2 pi 0, they're all on this line. All right, so now I need to decide, is my graph going up first to my maximum, or is it going down first to my minimum? And that all depends on whether my leading coefficient is positive or negative. Positive is going to go up first, negative is going to go down first. And I see a positive leading coefficient, so I'm going up first to the maximum. So that leaves this to be my minimum. And remember how I said we get max and minimum. Take your amplitude. We are 2 units above the midline for our max, and we're 2 units below the midline for the minimum. That's the distance from the midline up and down to our max and minimum. So 2 units above our midline of 0 is going to give me a maximum of 2. 2 units below our midline of 0 is going to give me a minimum of negative 2. So let's plot those final 2 points. Pi over 2, 2, and 3 pi over 2, negative 2. Remember, our next step was to take these 5 points and connect them in a smooth curve. This is a sine wave, it's a sine curve, not jagged V shapes. And then finally, to show that it's extended in both directions, we do use arrows. And then we're finished. So when I'm looking at a graph like this, what I'm checking for, do I see 5 points in the correct place? Do I see a smooth curve? And do I see arrows? All right, let's try this one. Sine of x plus 1. There's nothing out in front as a leading coefficient. So the amplitude is that understood 1, and its absolute value is still 1. Length of the period is always the same. From beginning to end, our graph should be 2 pi units long. No shifting left or right. But this graph finally does have a vertical shift. We're moving our graph up 1 unit. So I'm going to go up 1 and draw a dotted line. All right, let's fill in all of our x values. We know these are the same as the last ones. So I said for math 3, they will be the same. All right, let's fill in our y values. Start, middle, and end all have the same y value, and they're the same as your midline. Your midline's up at 1. So they're all at 1. Let's plot those points and make sure they're in the right spot. They are on this dotted line. 0, 1, pi 1, and 2 pi 1. All right, and then we have our max and minimum. Which one do we hit first? Well, because our graph is positive, we're going to hit our maximum first. We're going to go up, then down. Amplitude is just 1. So my maximum is 1 above the midline. We're at 1 for the midline, so the maximum 1 above 1 is 2. The minimum is 1 below. So 1 below 1 is 0. So let's plot our final 2 points. Pi over 2, 2. 3 pi over 2, 0. Connect in a smooth curve and draw arrows. All right, so this graph has all three things. It's leading with a negative. It's got something in here as a different amplitude rather than 1, and we do have some kind of vertical shift. So let's see how this graph looks. Absolute value of our leading coefficient is our amplitude, so it's just 2. Period's still going to be the same. No phase shift. We don't do that in this class. And there is a vertical shift because it's a negative 2. This graph is shifting down 2 units. All right, let's put in all those x values. All right, our y values, start, middle, and end are the same as your midline. Let's draw in our midline. If we're going down 2, here's the middle of our graph. And so negative 2 is the y value for our start, our middle, and our end. The remaining 2 points, max and minimum. This time, because our graph's negative, instead of going up first to the maximum, we're going to go down first to the minimum. So the minimum is 2 below. The reason it's 2 is because our amplitude's 2. 2 below the midline. If we're at negative 2 and we go down 2, now we're at negative 4. And the maximum is going to be 2 above our midline. If our midline's at negative 2, the maximum is going to be located at 0. So 0, negative 2 is the first point. Pi over 2, negative 4. Pi, negative 2. 3 pi over 2, 0. And 2 pi, negative 2. As you're graphing these, something to notice. And again, arrows. Something to notice should be, this is your amplitude and so is this. So these curves should be equal. If you finish graphing and you have something like this, where this is the midline, you've done something wrong because this distance is way shorter than this distance. These two halves should be mirror images of each other. They should be the same width and they should be the same height. So something like this lets me know you've done something wrong. So always double check that. Does this look like that smooth curve where the halves are equal? All right, so we have 3 remaining graphs. I want to help you get this one set up. I'm going to list all the things here at the top and then give you a chance to come up with the critical points and a chance to graph it yourself. So let's list all the important things. Amplitude, absolute value of your leading coefficient. So absolute value of positive 4 is 4. What does that tell me? From the middle of my graph, I'm going to travel up 4 to get to my maximum, and I'm going to travel down 4 to get to my minimum. Period's always the same. No phase shift in any of our graphs. And this one does have a vertical shift of down 2 units. All right, so when you graph this, I'll give you some pointers. Go ahead and draw your midline first. So half of my graph should be below this line, half of my graph should be above this line. Fill in those x values, the same ones we have practiced over and over again. Look back at the last problem if you need to remember what exactly are those x values. And then find your y values, remembering that start, middle, and end all have the same y value, and they're the same as your vertical shift or midline. And then find your max and minimum. Maximum comes first if it's positive, minimum comes first if it's negative, and add and subtract your amplitude to the other y values to figure out where those will be. Take a minute or two and see if you can graph this one. All right, so here's what your graph should have looked like. I filled in those 5 x values we need to memorize. I filled in the corresponding y values. Start, middle, and end are the same. They're all on our midline, which happens to be at -2. Our maximum comes first because it is positive, so 4 units above -2. And if you need to graph it and work backwards and then write the points, that's okay too. So 4 units above here, if I count up, I'm at 2. And 4 units below to get to my minimum puts me down here off the graph at -6. All right, let's look at another one. Negative sine of x plus 2. I'm going to give you guys a chance to do this one completely on your own. List your amplitude, your period. We know there's no phase shift. And your vertical shift. List your points and plot them. All right, same 5 x values. Midline was at +2. This has an amplitude of only 1. So from my midline of 2, I went up 1 and down 1, but I went down first because it's negative. So I went to my minimum first, then ended on my maximum. And you can check your ordered pairs, your graph, and the information at the top. All right, final question. Take a second and solve this one. Y equals 3 sine of x minus 1. All right, so let's check our answers. Amplitude was 3. So I went up 3 and down 3. I did go up first because it was positive, so we hit the maximum first. Period's always 2 pi, and this one shifts down 1. So here's my midline. That's also the y values for the start, middle, and end. Going 3 above our midline takes me to a maximum of 2, and 3 below takes me to a minimum of -4. So you're going to have 4 of these to work on your homework, and you can do that for the remainder of our time.